Welcome again to Symbolic Logic. I'm Mark Story. We're still in Bellevue College. For this video, we're going to see how to go beyond setting up a truth table to actually filling one out for single statements. The excitement just does not stop here, I know. Here I've got two statements kind of set up for you already. So we have these set up. We have a statement with only two different letters, A's and B's. So we have our 4 lines. Down below we have a statement with 3 different letters, so we have 8 lines. Kind of memorized to do that. We took our 4, cut it in half and got 2. So to set it up, we have 2 trues, 2 falses underneath the first letter. Under the next different letter, we have 1 true, 1 false, 1 true, 1 false. So we took 4, then 2, then 1. Now it's set up. We're just going to fill in some blanks afterwards. For this second statement, we have to start off with 8 lines. We take our 8, cut it in half, and get 4. 4 trues, 4 falses under the first letter. Under the next different letter, we take the 4, cut it in half, and get 2. 2 trues, 2 falses, 2 trues, 2 falses, all the way down. Then we go to the next different letter, and it'll always be the last one. Take your 2, cut it in half, and you get 1. 1 true, 1 false, 1 true, 1 false. And this truth table's set up and ready to go. So what we're going to do first is we want to be consistent. So if the A's are true, true, false, false, let's say that of all the A's. Let's make all the A's true, true, false, false. So I'll do that. So I'm just being consistent. That way, on row 1, all the A's are true. On row 2, they're true. On row 3, they're false. We've just been consistent. Once I've done that with all the letters, I next want to look at the operators. And I would say start off with the tilde that's kind of glued or right next to a letter. The tilde is just going to do the opposite of the letter it's next to. So if the A is true, true, false, false, the opposite would be, well, false, false, true, true. I'll write that down. Okay, so we got those blanks filled in. It's not a rule, but a good rule of thumb, if you will. It'll work now inside the parentheses. Do the main operator last. So inside the parentheses, we want to fill in this wedge column. Now the left disjunct is A, true, true, false, false. The right disjunct is this tilde. It's a negation. So the main operator of this thing here is the tilde. So I'm looking at this thing and this thing. And a wedge is going to be false only if both sides are false. Like right, well, there's no place. They're going to be true in every single case. So I'll make all these true. I got those blanks filled in. Here's a wedge again. Okay. Here's the main operator, so I'll star it here. It's the big important one. The right disjunct is just B. So I'm looking at that column here. The main operator on the left side is going to be this wedge. So I look at the main operator on the right, the main operator on the left, and I look at those 2 columns to figure out what the wedge is. Again, I'm looking for situations where they're both false, and I don't see anything like that. It looks like the wedge is going to be true all the way down. Okay. Now the truth table is complete. And we're going to be able to learn something from this here in a second. But let's do one more. Just one more example. This time an 8-liner. I don't see any tildes, and I don't see any other letters to fill in, so let's start inside the parentheses. We have a dot here, and the only way a dot is going to be true is if both sides are true, like right there. So I'm going to look for true trues. Do I see any others? I see one right here, and that's all I see. All these others will be false. So I'm just making all these others false. So we just filled in the dot blank, the dot column. Now here's the main operator. We'll go ahead and star that one. I look at the antecedent, which is D, and then the consequent, the main operator, the consequent is going to be that dot. And again, with the horseshoe, horseshoes will be false only if you have a true antecedent and false consequent. TF, I call it tough. So I'm looking for a tough combination. Here's one right here in row 2. And there's another one in row 3. Another one in row 4. I don't see any others. So all the others are going to be true. Here we have a complete truth table. All the blanks are filled in. You have a column of T's and F's underneath every single letter and underneath every single operator. At this point, we can now take a look at it and learn something from it. For single statements, they're either going to be tautologies, contradictions, or contingencies. So if you have a tautology, and notice tautology starts with a T, all the truth values in the main operator will be true, which means this statement has to be true no matter what. It's impossible for this statement to be false. Making it a tautology, it just has to be true. If I saw nothing but F's underneath the main operator, that would be a contradiction. The statement is structured in such a way it just has to be false. Well, it's either going to have all T's, all F's, or it's going to be a combination, like this one here. We have at least one T, at least one F. This one's a contingency. A contingent statement is one that's true sometimes, false sometimes. It just kind of depends upon how the world's set up. So it looks like it depends on what the truth values of D, E, and M are as to whether the statement will be true or false. So it boils down to this. Do a complete truth table, filling in all the columns, no shortcuts. Fill in every single column, and then look at the main operator. We'll star the main operator column each time. There's always one main operator for each statement. And we'll look at that particular line, that particular column. If it's all T's, it's a tautology. If it's all F's, it's a contradiction. If it's a mix, it's a contingency. Good luck with it.